recently graduated with my master's in artificial intelligence from Carnegie Mellon. And before that, I did a bachelor's in systems engineering with specialization in robotics from the University of Illinois. I have worked at so many companies, it would be ridiculous to list them here, but it's been a very interesting journey across fields like uh, uh, research and development engineering to more computer science, electrical engineering, control systems. I've been around so many different areas and it's been fascinating. I definitely feel that artificial intelligence, machine learning is the place for me.
Cool, cool. Well, I gotta ask, how do you go from systems engineering to AI? What was your thought process there?
Yeah, so it was more so that it was a recognition of the sort of person that I wanted to be. So it's more of a emotional or philosophical rather than cerebral journey. I was just thinking to myself, what would be great for you to do when you're the person that you want to be? And I wanted to be the sort of person who could be helpful to the people that I care about in any situation. And and that's a pretty lofty goal, in any situation, when you walk into the room for people to be at peace because they know things will be kept, they know things will be better because you're there. That's not an easy thing to do. And I started learning about the nature of complexity, and even given a deterministic equation, how and all the variables, how you won't be able to predict the output. And in terms of managing complexity, AI seemed to be one of the best tools kits for that. And effectively, as long as I have data, a computer, I can start making my way towards developing some sort of answer that'll help the people around me. So it seems like the best vehicle to achieve that life goal.
And when did you stumble upon this realization?
This was while I was working with Cummins. So I just graduated with a bachelor's in systems engineering. Was spending a lot of time outside of work. I think one of the biggest issues that I've noticed with people in the tech space is that they can do technical things, but they have no direction in life. They don't know the difference between right and wrong. Instead, they use their technical skills as a justification of the goodness of themselves. So basically, using productivity as a proxy for
Hmm.
moral uh, superiority, which is not good. And I didn't want to be like that. I wanted to know right from wrong. And I just spent a lot of time reading tons of philosophy, educating myself better on morality. And while doing that, I stumbled upon this thought process of what I wanted to be. And then the technological component of AI being the best way to do that uh, became pretty obvious.
And do you feel so? I guess you worked for a few years, realized that, and then from that experience, then applied and pursued a master's in AI. Is that something you would recommend to most people to work maybe in the industry, figure out who you are, what it is you value, and then transition to that? Or what are your thoughts?
Yeah. So I'll be very blunt here.
Uh-huh.
The only reason for someone to follow that thought process that is recommended quite frequently to, after your bachelor's, work for a few years and then come back for your master's is so you can understand what working really is. A lot of people have no idea. A lot of people, especially and I hate to um, keep harping on the tech folks, but it's a problem that we have in our community. And I like to be very open about things. Is that we lack communication skills. I lacked communication skills for a very, very long time, and I still lack them now. I'm still improving.
I
Uh,
don't think so.
trust me, there are many times I slip up and say things that I shouldn't have, or there's a better way of communicating the ideas that I have. Um, so the communication skills is a really big issue in the tech community, and that is only going to be exponentially more obvious when you start working, right? Because the general tech person, the way that they're or technical person, STEM field, the way that their mind works is if something is wrong, it's wrong, right? And unfortunately, that is insufficient requirement for useful communication in the in the business world. So they walk into a company, someone's giving a presentation, and they ask for your perspective on it. You say, "Well, this is wrong," and you don't know that you said, "Well, this is wrong," about in a way about a project that's effectively been someone who is very important's baby. It's been something they've been nurturing over months, and they've been really thinking about this. And you come in with a lack of appreciation, lack of effort to try and understand. Rather, you want to take a very black and white approach to uh, absorbing the problem and responding to it. And for lack of a better term, you end up hurting people's feelings that you definitely shouldn't be hurting, or not recognizing the best way to phrase your criticism, because people are not compilers, and right and wrong is the right level of granularity. When your code isn't working, okay, well, that's wrong, but you need more characteristics than right or wrong, and also tone development. Is it the right place to communicate what you're saying, uh, before you can deliver that to a human being, right? So what often happens is people come out of their bachelor's, they they go into the world, they start working, and they make tons of enemies. They have a lot of difficulty in moving forward in their career. They ask someone for something, it's like, why am I not getting it? Maybe it's because of the way you ask. Maybe it's because you haven't made the right friends. Maybe it's because you don't take the time to understand people. Maybe it's because you assume your day is harder than theirs. You know, so all of these different issues. That's the first part in communication, and
And
this is
are you speaking from personal experience on the enemy front?
well, you can't be everyone's friend, but I never intend to be anyone's enemy, and I much prefer to avoid that. I just show up at work and try to work and do good work. Um, but Yeah, so unfortunately, like everyone, had a variety of different experiences, but I also think that's positive because you can learn from them if you pay attention. So back on the communication, that's one of the issues. The second issue is not understanding how your work needs to be delivered, right? Because when you're in school and you're doing all this technical stuff, there is a gap between understanding a business problem, addressing it with the right technical solution, communicating it with stakeholders, and getting that buy-in. So it's a bit of communication, but it's also recognizing how to translate business problem into technical solution, communicating that. So those are the two major areas where uh, people need to upskill in before doing their masters, because a master's, you're at a much higher level. PhD, you're at a much higher level. So the stakes are raised when you start your career. You should have these things in check. So unfortunately, a lot of people don't have that skill set. And so it's very beneficial to take the time to do a couple years working before you get your master's, so you can get exposed to what working really is in the real world. Because there's all sorts of things going on. You can't even believe it. So you need to understand that. And if you already understand that, perhaps through series of internships or co-ops, then there is no need for you to work for a couple of years before doing your master's, because that's really a cushion, such that when you start your master's, or when you finish your master's, you don't flop at the first job that you start.
Yeah, yeah. And how certain were you that, when you applied to your master's and you started doing it, this is what I wanted to do?
100%.
Okay.
No confusion whatsoever.
Okay. And is that your recommendation to other people? Because I know, like in undergrad, some people go into college not knowing, like, hey, like, do I want to do computer science? I'm not sure. Maybe I should try it out and kind of ride the wave. Do you recommend that on a master level, or what's your thoughts? Yeah.
Yeah. Um, well, there's a lot of considerations there, because unless it's a fully funded master's program, you're going into it and you're not really sure what you're doing, and you're about to come out with $100,000 in debt. That is not something I can recommend. But I would like to put a disclaimer that I'm naturally pretty against general advice to people.
Mm.
Uh, I prefer to talk to people at a one-on-one level before, and just to explain why that is. It's so averages, something that you can use in, machine learning, statistics to get a sense, um, maybe for imputation or something like that. But in terms of the human experience, recommending an average piece of advice to someone is not a good idea. It's kind of like if you had an ice rink, and you just were gonna, and the whole city was gonna come into the ice rink, and you're just going to give everyone the average pair of shoes. I tell you what, you're gonna have a horrible mess in there. So I don't like giving general advice. What I will say is that people need to look at their situation. It may be the best available option to them, but certainly if you don't have it fully funded, you need to think very deeply about whether you should be doing a master's in something that you aren't 100% confident in.
Awesome. Very interesting analogy. Excellent advice.
Yeah, I'm a
Okay.
bad ice skater, so even with the right shoes, I probably make a mess.
Cool. Cool. Okay. Well, I gotta ask for our viewers as well as a bit for myself. Like, what is machine learning?
Machine learning is the process of using uh, techniques on data to allow the system to improve over time. And the black block of those techniques is usually some optimization algorithm. Um, Now, I would, it depends if you want me to go into the details. There's convex and non-convex optimization. You're not going to be dealing with anything in an actual environment that's going to be convex. That's like the simplest thing in the world. So you'll be optimizing non-convex algorithms, and the simplest way to do that is with gradient descent. But there are many different spin-offs of that. So that's the general framework. Is you have some data, you have some optimization algorithm, which represents how you're going to get your model, which is just a bunch of computation to try and improve on that objective over time.
And you're training the model and using actual results to determine the accuracy, and from there iterate. Right? Is that a component of it as well?
Yeah, so you can do accuracy. It doesn't have to be accuracy, though. There are many different metrics that you could use to evaluate. But yeah, sure, you could use accuracy. That's a very common one.
And what is a term that I've heard a lot is deep learning and AI. What is that? Like, is machine learning a subset of AI, or could you elaborate on the other two things?
Deep learning is a subset of machine learning.
Right.
Machine learning is that general framework where you have some system of computation, so multiplications, vector multiplications, convolutions, pooling, whatever, some computation, right? Uh, is the machine learning aspect of it. And then you have some optimization algorithm on top of that with the objective function that's going to try and improve that over time. Now, the deep learning aspect is a subset of machine learning where you're talking about neural networks, but not only neural networks, but neural networks that are deep, meaning the I think the technical, I might be wrong on this, but the technical depth question is from the end node to the start node, the number of hidden layers between. I believe a model is considered deep if it has more than four.
Okay. Could you give an example of maybe a machine learning application, and what the machine learning part of it is for the audience?
Sure. So maybe a simple one because they can see us would be face detection.
Okay.
So you can so we could take a screenshot and that would be a picture. And you'd want to use a convolutional neural network, which would also be deep, to learn the difference between a face and not a face. So you need to provide the model tons of examples of what is not a face and tons of examples of what is a face. There's also things like shortcut learning, where it might start to learn other features that are not actually indicative of a face. So, I mean, there are interesting ways you need to prepare your data. So, for instance, maybe perhaps with faces, people are always wearing um, shirts, right? So the model could actually just be trying to detect shirts in the images that you're giving it as opposed to faces. And that could be a quick shortcut that the model could take. So there are ways you have to make sure your data is sufficiently robust to ensure that the machine learning paradigm that you set up is going to actually return the results that you expect.
And so, okay, so you covered, one of the examples, face detection. Are there like certain like what are the different areas of ML, like the natural language processing? Like what are the different areas that people can look into to say, hey, like what am I interested? What should I invest my time into?
Yeah, well, Um, that's a really big question. There are tons of areas in artificial intelligence, machine learning. I'll just list off, and I really mean tons. I can just start listing off some. So, obviously, with respect to the visual, there's um, detection of really anything. You can also work with video, object tracking, uh, planning, so trajectory planning of something. You can um, work in natural language processing, which is a big thing right now. So teaching models to speak in a way that we can understand, um, fine tuning them, or prompting them such that they behave in very particular modes. Um, that's really been taken to the next level with RLHF, reinforcement learning with human feedback. Um, then, if you're going deeper into the actual machine learning components, there's just a lot, man. I mean, you can work on the right objective functions, the um, right ways to normalize, and I mean, different regularization you could focus on, different types of optimization. There's initialization. There's just so much that transfer learning, self-supervised, adversarial. There's so much in machine learning space that a person can really just spend their whole career in. It's absurd. So um, I think it really, if you have an interest, something that you want to look into machine learning or something you don't understand, I guarantee there's a pretty mature area of literature that you'd be able to get your hands dirty in.
Are you familiar with any of those literatures? Like, how does someone who wants to invest time in learning about machine learning go about doing that? Do you think
Yeah,
a formal, I know you hate general advice, but like, do you think a
yeah.
formal background really helps, or can you get your hands dirty on Kaggle or something? What are your thoughts on
So
that?
here's the thing, right? So anyone can find some data science, like from towards data science article and like copy code, which I presume is what quite a lot of people do. Um, I'm not above that myself. Stack Overflow. I've copied many lines of code in my life. Um, but so the issue with machine learning is that you have that if you want to do things well or complicated, you have to usually understand what it is you're doing. Um, because if something goes wrong, you need to know how to fix it. And it's not like a light bulb. where, oh, it's not on, like, is it on or is it off? Like, it's not just a single button. There are many different interconnected things that are happening here. So in order to really get into machine learning, if you really want to understand it, and at an advanced or expert level, there's no way to escape uh, the path of learning. That path of learning is going to include, um, obviously, standard computer science, just understanding the right way to write code, modularity, inheritance, all that kind of stuff. Then you're going to need to also have a very strong math background, linear algebra, calculus, different. I don't think you need differential equations actually, but definitely understanding chain rule, Jacobian, how to take derivatives of multivariable functions, optimization, probability and statistics, um, eigenvalues, eigenvectors. There's a lot in math that you have to know. And once you know, and those are prerequisites, I'm saying. So when you know those things, then you can begin really getting into trying to understand what it is machine learning models are doing, so that they can be useful. But if you don't understand the things I just talked about, you're not, you're just not going to get it.
So could you go by calling the functions and whatnot, but you won't really fully understand it, or you really do need the background to even get started? Or
So you'll be able. The thing is, you're just going to fail eventually, and you won't be
okay,
able to help
and
yourself.
okay,
Um, so I don't know if I have a. Let me think if I have a good analogy for this. So it's sort of like fake it till you make it.
mm,
You could probably walk into a hospital, if you're good looking, clean shaved and all that, wearing the white coat. It's like, hey, how you doing? You can make your way probably to the operating. Oh, I forgot my badge. Laura's down there. I'll go. You could probably, uh, schmooze your way, to the operating room. When you have the scalpel, might as well be standing there with the stapler, because you aren't going to be able to do anything when it when it really matters, when things get complicated. So I think you'll be able to, maybe have some fun with like some Kaggle competitions, or some things at a hackathon, or have like some projects to show people. But um, if you actually want to be able to fix, tune, and understand what is happening to modify and use artificial intelligence at a very high level, you cannot skip what I mentioned.